From the table shown here and our previous knowledge, let us draw some similarities and differences between derivatives and antiderivatives. If you carefully observe the table, you can immediately say that differentiation and integration operate on functions. The functions could be polynomial, logarithmic, exponential, and trigonometric. Also, you have learned that the derivative and the integral of the sum or difference of two or more functions is the sum or difference of the derivatives or the integrals of the functions. In other words, differentiation and integration both satisfy the property of linearity. In mathematics, the property of linearity of differentiation and integration is the most important fundamental property. For example, if y is equal to 10 log x plus 4 sin x, then the derivative of a function y with respect to x, that is, dy by dx, is equal to d by dx of 10 into log x plus 4 into sin x, or 10 into d by dx of log x plus 4 into d by dx of sin x. Similarly, integral of 10 by x plus 4 cos x dx is written as 10 into integral of 1 by x dx plus 4 into integral of cos x dx. Note that the integral of a function need not exist. If a function f of x has an integral, then f of x is called an integrable function. A similarity while calculating the derivative or integral of a function is that all functions may not be differentiable and may not be integrable. For example, the function f of x is equal to modulus of x minus 2, where x belongs to the set of real numbers, is not differentiable at x is equal to 2. Let's prove it. This is the given function. We know that modulus of x minus 2 is equal to x minus 2 when x is greater than or equal to 2, and is equal to minus of x minus 2 when x is less than 2. Now, let's see whether the function is differentiable at x is equal to 2. Consider the left-hand limit. It is equal to minus 1. On evaluating the right-hand limit, we get it equal to 1. Since the left-hand limit and the right-hand limit at x is equal to 2 are not equal, limit h tends to 0. F of 2 plus h minus f of 2 divided by h does not exist. Therefore, f is not differentiable at 2, and hence is not a differentiable function. Now, let's consider f of x is equal to sin x by x. Integral of f of x dx is equal to integral of sin x divided by x dx. However, it is not possible to find the integral of sin x by x dx by inspection, since we cannot find a function whose derivative is sin x by x. Hence, f of x is equal to sin x by x is not integrable. Next, we will discuss a difference between differentiation and integration. The derivative of a function, if if it exists, is unique. On the other hand, if the integral of a function exists, then it is not unique. Any two integrals of a function differ by a constant. Let's see an example. The derivative of x squared plus 2 is equal to 2x, whereas the integral of 2x dx is equal to x squared plus c, where c is the constant of integration. Different values of c will correspond to different members of the family. Hence, a function does not have a unique integral. Another difference between differentiation and integration is that when a polynomial function is differentiated, the result is a polynomial function whose degree is 1 less than the degree of the original polynomial function. On the other hand, when a polynomial function is integrated, then the result is a polynomial function whose degree is 1 more than the degree of the original polynomial function. Let's see an example. Let f of x be a polynomial function equal to x cubed minus 2x squared plus 5x minus 1. Here, the degree of f of x is 3. Now, on differentiating both the sides, we get f dash of x is equal to 3x squared minus 4x plus 5. Here the degree of f dash of x is 2. This shows that when a polynomial function is differentiated, the result is a polynomial function with degree is 1 less than the degree of the original polynomial function. Let's consider the same polynomial function again. Now, let's integrate it with respect to x. This is equal to integral of x cubed dx minus 2 into integral of x squared dx plus 5 into integral x dx minus integral dx. On further simplification, we get the value of the integral as shown here. Observe that in this case, the degree of the polynomial function is 1 more than the original function. The derivative of a function can be found at a point, but the integral of a function can be found over an interval. This point will be discussed later in a forthcoming module. The geometrical meaning of the derivative of a function is the slope of the tangent corresponding to the curve at a point. That is, for the curve y is equal to f of x, the tangent at P can be obtained by finding the derivative of the function at P. An indefinite integral can be represented geometrically. It is a family of curves placed parallel to each other and having parallel tangents at the points of intersection of the curves of the family with lines orthogonal to the axis representing the variable of integration. Consider these functions. Now, on drawing the curves for these functions, we can observe that they are parallel to each other. Also, the tangents drawn at the points of intersection of the curves of the family with lines orthogonal to the axis are parallel, and they represent the variable of integration. Now, let us compare how differentiation and integration are used. Derivatives are useful in finding some physical quantity, like the velocity of a moving particle. On the other hand, integrals are useful in finding out the displacement when the velocity of a particle at time t is given. For example, if the displacement of a moving particle is defined as s is equal to 5t squared minus 2t plus 7 units, then let's find its velocity at t is equal to 3 seconds. Consider the given function. On differentiating both the sides with respect to time t, we get ds by dt is equal to 10t minus 2. We know that velocity is equal to ds by dt. Thus, the velocity of the moving particle at t is equal to 3 seconds is 28 units per second. Hence the velocity is 28 units per second. Now, let us find the displacement of a body given its velocity. Suppose the velocity of a moving particle is given by the relation v is equal to 2 plus 4t units per second. Find the displacement after 5 seconds. Let's begin with the solution. The function is as shown. We know that when we integrate velocity, we get the displacement. So, let's integrate the given function on both the sides with respect to time t. This gives displacement s is equal to 2 into integral of dt plus 4 into integral of t dt. On simplification, we get displacement s is equal to 2t plus 2t square. Now, let's find the displacement at t is equal to 5 seconds. This gives s is equal to 60 units. Hence, the displacement after 5 seconds is equal to 60 units. One more similarity between differentiation and integration is that both the processes involve limits. This we will discuss in detail in a forthcoming module. Lastly, the processes of differentiation and integration are inverses of each other. For example, the derivative of sin x is cos x, whereas an integral of cos x is equal to sin x plus c, where c is the constant of integration.